The deluge fire protection systems are installed to protect extra hazard occupancies requiring significant amounts of water in order to cool and control the growth or development of fire. Typically, they are employed on hazards that contain low flash point flammable liquids or hazards with large amounts of combustible liquids. The deluge fire protection system depends on the presence of a deluge valve that controls the flow of highly pressurized fire extinguishing fluid to the sprinkles or nozzles when a temperature element senses high temperature on the protected equipment. The deluge valve consists of two chambers, a main chamber in which there is the motion of opening and closing the deluge valve, and a priming chamber, or may be referred as the sensing chamber, in which there is the motion of the diaphragm responsible of opening and closing the deluge valve. The position of the deluge valve depends on the differential pressure between the priming chamber water pressure and the water supply pressure. In the shown figure, the deluge valve is in normal closed position, where the priming water pressure is pushing the diaphragm in forward position, which is connected to the plunger, forcing the clapper to close the deluge valve cover and overcoming the water supply pressure. Therefore, the priming water pressure behind the diaphragm is balancing the water supply pressure, causing the deluge valve to be closed. In the shown figure, the release of the priming water pressure behind the diaphragm caused the diaphragm together with the plunger to move backwards, removing the pressure on the clapper, consequently opening the deluge valve by the action of the water supply pressure. This photo shows the deluge valve in normally closed position, where the priming water pressure is 12.5 bar while the water supply pressure is 8 bar. The priming water pressure branches from the water supply pressure, so normally there should be a zero differential pressure between them, which is essential for the deluge valve to remain closed. However, the priming chamber here indicates a higher pressure, which is common to all the deluge skids present on site. This could be explained due to the presence of a check valve before the priming chamber. When the pressure of the fire water ring rises, the water supply pressure rises, causing the priming pressure to rise. When the pressure in the fire water ring falls again, the priming pressure remains high, due to the presence of the check valve which prevents the priming pressure to fall. The presence of the check valve is essential to ensure that the priming chamber is pressurized, and won't depressurize if the pressure of the water supply falls. There are several methods for operating the deluge valve system, all of which depending on depressurizing the priming water pressure to open the deluge valve. The deluge valve can be operated manually using the emergency release valve that is present on the priming loop. Other method for activating the deluge system is by activating the solenoid valve, which is also present on the priming loop. This can be activated either manually by a push button in the control room or automatically from the fire and gas panel in case of a temperature element senses a high temperature on the protected equipment. This diagram shows the action of activating the solenoid valve in a deluge system. Showing the deluge valve is in closed position. The blue color represents pressurized water pressure, while the orange color represents atmospheric air. Here is the water supply pressure, while here is the priming water pressure, which is forcing the diaphragm in forward position, balancing the water supply pressure and keeping the deluge valve in closed position. The priming loop branches from the water supply pressure. The priming loop includes a manual valve, a strainer, and a check valve which was mentioned earlier. The priming loop also includes the solenoid valve, which can be activated from the push button in the control room. Also present on the priming loop, the emergency release valve that can be operated manually to activate the deluge system. The emergency release valve and the solenoid valve are connected from one end with the priming water pressure and connected to the drain open to the atmosphere from the other end. Here is the high pressure switch that is present on the outlet of the deluge valve, which gives an alarm signal in case of sensing supply water pressure. This alarm signal serves as an indication for activating the deluge system and may take actions according to the fire and gas system. Here is the outlet of the deluge system that is connected to the sprinkles or nozzles. In case of fire, when the operator presses the push button in the control room, it sends a signal to the solenoid valve, opening the path to the drain, consequently depressurizing the priming chamber pressure, causing the water supply to move the diaphragm and pushes it backward to allow the water to reach the sprinkles or nozzles. Let's see the system in action. Another method of activating the deluge system would be the dry pilot actuator. Here is a diagram to explain the operation of a dry pilot actuator in the deluge system. The yellow color represents pressurized air between the dry pilot actuator and the sensing element. The blue color represents pressurized water, while the orange color represents atmospheric air. The dry pilot actuator is connected to the priming loop from one side and to the drain from the other side, open to the atmosphere. In case of a sensing element senses high temperature, the pressure on top of the dry pilot actuator is released, opening the path to the drain. Therefore, the priming pressure is released, opening the deluge system. Here is the system in action. Here is a diagram explaining the operation of the dry pilot actuator. In the shown figure, the valve is in closed position, where pressurized air on the piston and diaphragm assembly works as a seal between the inlet and the outlet of the valve. When activated, the pressurized air above the piston is released. Therefore, the water pressure together with the spring force pushes the piston and the diaphragm assembly upwards, allowing water to pass from the inlet to the outlet drain, consequently depressurizing the priming chamber pressure and activating the deluge system. During the activation of the deluge system, it is necessary to ensure not to fill the priming chamber with water pressure by mistake, which consequently will close the deluge valve, and here comes the role of the pressure-operated relief valve. The pressure-operated relief valve is also present on the priming loop, which continuously drains the priming pressure when the system is in activation. Shown here is the diagram of a pressure-operated relief valve. In the shown figure, the valve is in closed position, where there is water pressure on the valve inlet, forcing the seat to seal between the inlet and the outlet to the drain. In case the deluge system is activated, water pressure comes from the top to overcome the water pressure present in the inlet, forcing the seat to move downwards to open the path between the inlet and the drain outlet, allowing the priming water pressure to be drained during the deluge valve operation. In Ibjetco plant, the deluge system is installed in 3 different areas. 5 deluge skids are installed at the storage area in order to cool down the temperature of the storage spheres, in case of any temperature rise is detected. These skids are equipped with 2 methods of operation in order to increase the protection on the storage spheres. It can be operated manually from the control room by the solenoid valve or automatically by the dry pilot actuator in case of a temperature element senses high temperature. One skid is installed at the process area in order to cool down the depropanizer and deethanizer accumulators in case there is a rise in temperature. Another skid is installed besides the warehouse in order to service the truck loading area. This skid has a bladder tank equipped with foam. The scope of this skid is different than the other skids, since it doesn't only cool down the required equipment, but it also fights fire using foam mixed with water in order to control fire in any emergency situation or liquid spillage in the truck loading area. For all the deluge skids, they can be activated manually on site using the emergency release valve or by using the bypass valve in case that the deluge valve is in maintenance. Also, all the skids can be operated manually from the control room by the push button.